Let's combine what we learned in the previous two videos to resolve vectors. So we learned about how know your right angle triangles. We also learned about SOHCAHTOA. So let's combine them together. Okay, so now imagine I have a vector A here, and this vector, if I put it on an xy coordinates, it's not lying on the x-axis, it's not lying on the y-axis. It's lying at a certain angle which we call theta. Okay, this theta right here is measured with respect to the y-axis here, not the x-axis. Okay, in any situation, it can be measured with respect to the y-axis or the x-axis. But now this is the information that they give. A has a magnitude, this vector A here has a magnitude of 10 meter, and this angle here is 30 degree. Okay, so now if you want to resolve it, what do? We draw dotted lines that is perpendicular to the y-axis. We draw a dotted line that is perpendicular to the x-axis. We have discussed this earlier. Then we know that one side, the side that is on the x-axis will be the x component of A, whereas this side will be the y component of A. Okay, so we draw this on the diagram first. So this is us trying to analyze it graphically first. Okay, so now we know that we need to use our SOHCAHTOA. That means we have to know where is our right angle triangle, because SOHCAHTOA is applied only to right angle triangle. So where is our right angle triangle in this case? Okay, so here I draw for you the right angle triangle. As you can see here, this blue right angle triangle here has a 90 degree over here, and the theta must be included in the right angle triangle. If you don't include the theta, then you don't know where is the theta anymore. Okay, so include the theta in the right angle triangle, and the vector must be the hypotenuse side of the triangle. The vector A must be the hypotenuse side, and your triangle must include the angle inside. Okay, that's how you draw a right angle triangle. So now we can know where's the hypotenuse. It's opposite the 90 degree. Then you know opposite this angle theta here is our opposite. Beside the angle theta here is adjacent. Okay, so now once you know that already, right, you can actually start to find AX and AY. Okay, AX is here, even though AX is not included in the right angle triangle, but I believe you can see that AX here has the same length as the opposite side of the blue right angle triangle over here. AX here, same length with the opposite side of the triangle. So actually, if you want to find AX, what we are finding is we are finding the opposite side of the triangle. So if it's the opposite side that we want to know, the hypotenuse we are given, then the equation that we should pick is the first equation up here. Because we are interested with opposite side, we are given the hypotenuse, we are given the angle. So now we can put this equation, bring it down, substitute opposite with AX because that's the opposite that we want to find. Substitute the hypotenuse with the length of this vector A, or the magnitude of this vector A. See here, this A here has no right arrow because this A here is just representing the magnitude. It's not does not consist of any direction anymore. So this is just the magnitude only without the arrow on top. Okay. So if we rearrange the equation, bring the hypotenuse to this side, then AX is equals to A sine theta. Okay, we stop here for AX, let's go to AY. AY is over here, is exactly on the adjacent side of the triangle, right? So we know that AY will be the adjacent side. So if we are interested with adjacent, we have hypotenuse, then the equation that we should apply should be this second equation over here. Because we are interested to know the adjacent, we already given the hypotenuse and the angle. So this is the equation to apply. Bring it down, substitute. Adjacent is AY, then the hypotenuse is the magnitude of the vector A, which is just A. Okay, rearrange, then you get AY is equals to A cos theta. Okay, now if you are really excited, then you want to start to substitute a is equals to 10, you want to substitute theta is equals to 30, well, that's where you start to get it wrong. Okay, before you start to do anything, you have to remember that we have positive side of the x-axis, negative side of the x-axis, positive side of the y-axis, negative side of the y-axis. The direction is also something we need to care about. Okay, so I mentioned last time that when you're writing components, you don't need to write direction. But how do we take care of direction is like this. If you consider the direction, we know that AX is pointing in the positive X direction, then AX is just the equation without any changes. But AY here is pointing in the negative Y direction. Negative is going downwards, right? In that case, you have to introduce a negative to the equation. Okay, so don't straight away substitute what you have inside the equation and find your components, because if you do it that way, right, your AX and AY must be positive. If you don't consider, your AX and AY will only be positive if you don't consider the direction. But when we are doing components, direction is important, because if it's pointing to the negative side, it will be a negative value. So if it's pointing to the negative side, it's a negative value. If it's pointing to the positive side, it's a positive value. If a positive, don't write anything, it's positive. Okay, now only after you consider the direction, when you start to do your substitution. So for AX, we sub in A, we sub in theta, we calculate our answer to be 5 Newton. For AY, remember, bring along the negative sign, substitute A, substitute theta, then there you get your negative 8.7. Now you see, 5 Newton here, Newton should be meter. Sorry, this is my mistake. The unit should be in meter. Okay, take note, meter. So AX here, it's pointing to the right, thus the value is positive. AY here is pointing to the negative downwards, therefore it's a negative value. So always double check once you get your components, is it in the right sign? Okay, I didn't double check the unit, that's my fault. Okay, so this is a simple example of how you do your resolving vectors. But again, in an exam, what we need to see is only this part of the working. You don't need to write all this in your working. This is the thing that you need to think about in your brain. But if you are not familiar, feel free to write it down. But the most important thing that we check is this part of the stuff.